Hello, welcome again. We are solving GATE 2016 Aerospace Engineering paper. Question number 40 is a channel section shown in figure has uniform thickness. It is subjected to an anti-clockwise torque of 62.5 into 10 power 3 Newton mm. The maximum possible thickness of channel section such that the shear stress induced in does not exceed 100 Newton per mm square is dash mm. So this is 100 mm, this is 100 mm, this is 100 mm. Okay. Now this is your thin wall section and open section. And for the thin walled open section, the tau max is given by 3t divided by summation of db square, where d is length of each member. Here the length is 100 mm, this is 100 mm, and b is thickness. Okay. So so there are three members, so it will be 100 b square plus 100 b square plus 100 b square. Okay, and tau max is given as 100, so from this we get b as 2.5 mm. So answer is 2.5 mm. Next, question number 41. The differential equation of motion of a damped system is given by m d square x by dt square plus c dx by dt plus kx is equal to 0. If m is 1 kg, c is 2 Newton second per meter and k is 2 Newton per meter, then the frequency of damped oscillation of this system is dash radian per second. So natural frequency is omega n is equal to root k by m, and this is k is your 2, m is 1, so this is root 2. Okay, and damping ratio is c by c divided by 2 root km. So k is your c is given as 2 and k is your 2, and so damping ratio is 1 by root 2. Okay, and the damped frequency is omega d is equal to root 1 by 1 minus uh, tau square into omega n. Okay, so putting the value of omega n, tau, and we get value of damped frequency, that is 1 radian per second. Okay, so next, the two-dimensional state of stress in a body is described by Airy's stress function. Phi is equal to 5 x4 by 12 plus x cube y by 6 plus 3x square y square by 2 plus 7x y cube by 6 plus e y4 by 12. The Airy's stress function will satisfy the equilibrium and compatibility requirement if and only if the value of coefficient E is. So here that is the Airy's stress function, and for satisfying the compatibility and equilibrium equation, this condition should be satisfied. Curly 4 pi by curly x4 plus curly 4 pi curly x square curly y square plus curly 4 pi divided by curly y4 should be equal to 0. So curly 4 by curly x4. So this is if we differentiate it 4 times with respect to x, then this quantity will be 0, because here it is only x cube. Okay, and this quantity will also be 0, this quantity will also be 0, and there is no x in it, so it will also be 0. So only left thing will be this, and its differentiation 4 times will be first time it will be 4x cube, second time it will be 3x square, third time it will be 2x, and fourth time it will be 1. So it will be 5 into 4 into 2 into 2 3 into 2 into 1 by 12. Okay, because 5 is already there, so 4 into 3 into 2 will come here, and 12 is already there, so it will be 5. Okay, now similarly, if we differentiate with respect to y, then this quantity will be 0 4 times y, then this quantity will be 0, this quantity will be 0, this will be 0, this will be 0, and here it will be e into 4 into 3 into 2 into 1. Okay, or by 12, so it will be e. Okay, and now if we differentiate 2 times with respect to x and 2 times with respect to y, so it will be if we differentiate with respect to y, it will be 0, and if we differentiate with respect to x, it will be 0, and if we differentiate with respect to y twice, it will be 0, and if we differentiate with respect to x twice, it will be 0. So now we'll perform the differentiation of this only. So it will be 3 into 2x 2 plus 3 into 2 into 2 into 1, okay, divided by 2. So this will be your 6. Okay, now when we put here these three things in this equation, we can find out E. So E comes out as minus 11. Okay. Next, the value of definite integral 0 to pi x sin x dx is dash. So I is x sin x, let I is x sin x dx, limit 0 to pi. So integrating by parts, so this is first keeping this thing x is same, and and integrating it, it will be minus x cos x. Now differentiating this part, x differentiation of x will be 1, and integrating this part minus cos x, and then now again performing integration. So this is the method to of integration by part. Okay. Now we can perform here integration again, and changing this minus and minus to plus. So cos x will be integration of cos x will be sin x. Okay, and if we put the limit, so we get the value I as pi or 3.14. Okay, so answer is 3.14. Next, use Newton-Raphson method to solve the equation x raised for x e x is equal to 1. Begin with initial guess x naught is equal to 0.5. The solution after one step is x dash equal to dash. So fx is 1 minus x ex is equal to 0. Taking this fx, taking this one here, and then taking it as fx. So f dash x is its differentiation will be 0, and it now differentiating it by using product rule. So that is x minus x ex and minus ex. Okay, differentiating with 1. Okay, so it will be minus ex bracket x plus b 1. Okay, so this is f dash x, and now according to Newton-Raphson method, x1 is your x naught minus fx by f dash x. So fx is this quantity 1 minus x ex, and f dash x this quantity. Okay, so if we put initial guess is 0.5, if we put x naught as 0.5, so we get x1 as 0.5704. So answer is 0.5700. Solving this,